we are now moving into radicals, which is also sometimes known as square root. So square roots or radicals are actually the opposite of exponents. It's what we use to undo an operation, just like addition's opposite is subtraction, multiplication is division. Exponents and square roots are opposites of each other. So when we take the square root, what we're actually finding is what number times itself is that number. So for example, if we want to find the square root of 64, we're asking what times what is equal to 64? And in this case, it's 8 times 8. Another way we can write that is 8 squared equals 64. So the square root of 64 is 8. Okay, so our final answer is 8. All right, for the square root of 121, so we're trying to find what number times itself is 121, and that would be 11. So that means that the square root of 121 would be 11. All right, so our next topic kind of is for numbers that we can't take the square root as easily. So the types of numbers that we just looked at are both perfect squares, meaning it has a nice whole number when we take the square root. But if I ask you to take the square root of 8, no number times itself will give us 8. So we're going to look at a strategy to allow us to find that. So I'm actually going to show you 2 different ways to do this just for the first couple of times, and then from there you can pick what's easiest for you. Now it's essentially the same thing, it's just the types of numbers you choose. So when I do it, I like to always start with a 2 if I can. So I'm always thinking 2 times what? So I'm going to think about 2 times what is 48? That's 24. Then I'm going to say 2 times what is 24? That's 12. 2 times what is 12? That's 6. 2 times what is 6? That's 3. And then I can't go anymore. So all of these numbers here, these are all prime numbers, meaning that they can't be, the factors of that number are itself and 1, okay? So I'm going to just be looking at my prime numbers, and this is kind of the weird, tricky part. So what you do is you actually look for pairs. So I have a pair of 2s and a pair of 2s, and then I have this lonely 3. So what I do is, because I have a pair of 2s, I'm going to do 2 for the pair of 2s, and then 2 for the pair of 2s, and then whatever is lonely stays inside the square root. So my final answer would be 4 root 3. So one trick I usually tell my students is the number that's by itself is lonely, so it stays inside because it has no friends, right? So let's look at a different way that we can do this prime factorization. So students always ask, well, do I have to use 2? Absolutely not. So you can just think of, like, what do you know? What 2 numbers you know that multiply to get 48? Most of the time we think of like 6 times 8. So what we have to do is we have to keep branching until we end up with prime numbers. 6 is not a prime number. So I can multiply 2 times 3. 2 times 3 is now prime. Okay, so we're kind of stuck. Now 8 is not a prime number. I could do 2 times 4. 2 is a prime number, but 4 is not, so I can do 2 times 2. So now I'm going to kind of look at all of my prime numbers, okay? So I highlighted them, and then I look for pairs. So I have a pair of 2s, I have a pair of 2s there, and then I have a lonely 3. So once again, it's 2 times 2 and then root 3. So we end up with 4 root 3. So obviously it's the same. Okay, looking at the square root of 200. So I'm going to do it this way first. Now, some of us are like, well, why would I do the 2 method? It's just because 2 is always an easy number to start with. So that's why a lot of people end up liking this way better than this other way. So 2 times 100, and then 2 times 50, then 2 times 25. Now here's where we get stuck. There's no 2 times something that can give me 25. So then you just go to the next highest number. 3, nope. 4, nope. So it has to be 5. And then we're stuck because 5 is a prime number. So I'm going to kind of identify my prime numbers here, and those are the numbers I'm dealing with. So I'm looking for pairs. So I have a pair of 2s, and I have a pair of 5s, and I have my lonely 2. So my pair of 2s times my pair of 5s, and then this lonely 2 stays inside. So 2 times 5 is 10, and then this would be root 2. Okay, now let's try it a different way. What if I think I'm going to use 50 times 4? Okay, so then 50 I can branch into 10 times 5. And then 5 is prime, so we're kind of stuck, but 10 I can do 2 times 5. And then 4 I can do 2 times 2, and then we're stuck. So I have 2, 5, 5, 2, 2. So those are all prime numbers. So then I have a pair of 5s, a pair of 2s, and a lonely 2. So it's 2 times 5, which is 10, root 2. So obviously the same as the last one. So how I'm going to do it is I'm actually going to do it the way with the 2s, just because some students, when they do the other way, they end up like forgetting numbers, and I just like the way it looks and is organized. So we're going to keep practicing. So for 60, I would have 2 times 30, then 2 times 15. Now I know that 2 does not go into 15, so I'll go to 3, and 3 times 5, and then both 3 and 5 cannot be branched. So I'm looking at my prime numbers. So I see a pair of 2s, so that would go on the outside. Now this time I have 2 lonely numbers, meaning they don't have pairs. So what we do is they both go on the inside, and you actually multiply them. So the final answer would be 2 root 15, because root 3 times root 5 is root 15. All right, let's look at root 24. So this would be 2 times 12, then 2 times 6, then 2 times 3. So I'm looking at all of my prime numbers, which is 2, 2, 2, and 3. And I have a pair of 2s, and then a lonely 2 and a lonely 3. So the pair of 2s goes on the outside, and then inside would be the 2 times 3. So my final answer would be 2 root 6. So all of the problems we've done so far are obviously with numbers. So we want to look at, well, what about variables? So for some students, this is actually way easier. And then on the other end, some of us find it very difficult. Like, how do I even take the square root when there's a variable? So I'll try and break this down. So keep in mind the square root is the opposite of squaring something. So if I ask you to find the square root of x squared, it ends up being just x, because you're undoing squaring. Okay, so with that in mind, if I want to find the square root of x to the 12th, what you're really doing is figuring out how many x squareds are in x to the 12th. Well, there's 6. So then it would just be x to the 6. And another easier way to think of it is just do, if I'm taking the square root, I'm just going to do 12 divided by 2. And that ends up being 6. Okay? But it gets a little complicated when it's not an even number. So like in this next example, we have x cubed. So I know that there is 1 x squared in there. So because of that, that will go on the outside. Okay? Now, the square root of y to the 4th, how many y squareds are in there? There's 2. But we still had that extra x that has to stay inside. Okay? So when you break this one down, you have x, 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 and then y, 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 y. So we're looking for pairs, right? So we have a pair of x's, a pair of y's, and a pair of y's. So we would have x and then one pair of x's, and then two pairs of y's. That's why we have y squared, but we have the lonely x on the outside, or in the square root. So looking at the next one, the square root of x to the 40, you can think of it as how many pairs of x squareds would I have? I'd have 20. So you could just do 40 divided by 2. So the final answer would be x to the 20. Okay, now looking at this one, so I know that there would be 3 pairs of x squareds. Okay, but I'm going to leave some space. I know I have 1 left over x. And then what's the square root of y to the 5th? So how many y squareds are in there? There's 2, but then 1 left over. So what you should be gathering is anytime you have an odd exponent, you will have a leftover that has to go into the square root or into the radical. All right, so the last thing we're going to do is kind of combine both numbers and variables. So our first one is the square root of 40x cubed. So how I do this is I do the number first, and then I do the variable. So I'm going to go back to our branching. We have 2 and 20, 2 and 10, 2 and 5. Okay, so I'm looking at all of my prime numbers. So I have a pair of 2's, and then my lonely guys will go inside the square root. So I know that I'm going to write this as 2 and then root 2 times 5. So I know that this will be 2 root 10, okay? But I also have, because you can kind of think of this as root 40 times root x cubed. So I also have that root x cubed. So I know that I can take out 1x, but then 1 would be left inside. So this would be like x root x. So when I write my final answer, I would have the 2 on the outside, the x on the outside, a 10 on the inside, and an x on the inside. So 2x root 10x. All right, let's go ahead and look at this next example. So again, we can think of this as root 216 times root v. Okay, so first we'll deal with the 216. So this would be 2 times 108, 2 times 54, 2 times 27. Now, 2 doesn't go into 27, but I could do 3 times 9, and then we have 3 and 3. So I'm looking at all of my prime numbers here, and I'm then looking for pairs. So we have a pair of 2, we have a pair of 3's, and then we have our lonely numbers. So the square root of 216, we would have 2 times 3 on the outside, because those are my pairs, so 6. And then on the inside, I would have the lonely numbers, 2 times 3, which would be 6. Now I'm going to deal with the square root of v. So unfortunately, I can't take any pairs if it's just v to the 1. So that v actually just stays inside the square root because there are no pairs with v to the first power. All right, our last one here. So for this one, this will take a while. 2 times 200, 2 times 100, 2 times 50, 2 times 25, and then 5 times 5. Not terrible. So I'm going to look at my prime numbers. Okay, and then I'm going to circle my pairs. So I have a pair of 2's, a pair of 2's, and a pair of 5's. So this one's kind of interesting because I don't have any lonely numbers. So when I multiply them, I would just do 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. So it would just be 20 on the outside and then nothing in the inside. So what this means is it's a perfect square. So the square root of 400 is just 20. So if we knew that, we actually didn't have to do all that branching. Okay, so now let's look at the next part, which is m cubed n to the 5th. So we want to think how many m squareds are in m cubed. There's 1, but then I have to leave 1 on the inside. And then I'm looking at n to the 5th. How many n squareds are in n to the 5th? There's 2, but then I have to leave 1 on the inside because it's left over. So your final answer would be 20mn squared, the square root of mn. So that is everything for radicals. And then what we're going to be doing next week is doing both exponents and radicals.